Good morning. Mm. Okay, good morning, Lokesh. Morning, Charan. Yes. Right. So power rating we were discussing for the bulb, isn't it? Bulb or for any appliance, we can say about the power rating. Power rating means what? Power consumption in a electrical appliance. Okay. Generally, it is the case of what? The bulb. Okay. So what is the power consumption in a bulb? Right. If it is connected in a circuit. Okay. So every bulb or every appliance have what? A given power rating. Okay, means this bulb or resistance is going to be consume this much power. But with the power, there is voltage also written. That means if this bulb is connected to this particular voltage, then it will consume that much power. But if I connect it to some different voltage, then it won't consume the same amount of power. Understood? So let's discuss one more example on that. What we learned it yesterday. Okay. Okay. So power consumed by the two batteries we have taken one example. Okay. Now let's take the similar example, 50 watt, 200 volt. Okay. In this example, what is given to us? That is the bulb one. That is another bulb. This is the bulb number three. And there is a battery connected. Okay. Just give me a moment. Okay. Okay. So there are three bulbs given to us in the question. This is the B1, B2, and B3 given to us. Rating is given like this 50 watt to 200 volt. Okay. Bulb 1 is what? 50 watt and 200 volt. Second bulb is given 50 watt, 100 volt given. And third one is given 100 watt and 200 volt. Okay. And we are going to connect a battery of let's call it 300 volt here. Okay, we are going to connect what? A battery of what? 300 volt. Internal resistance of the cell is 0. Okay, so now find power consumption in each bulb. Okay, find power consumption in each bulb, how much it is going to be, and Also, please check it that is there any bulb is getting fused or not. Okay, that is the first thing, find out. Second thing, which bulb will get fused. If it is going to be fused any one of the bulb, then we have to find out which one. If all are safe, then no problem. Okay, please tell me what is the answer coming for this question. What you will do first, you will calculate the resistance. You will calculate the resistance of each bulb. Okay, actually please calculate it. Start with calculation of resistance of each bulb. Okay. Okay, so tell me what is the resistance of these bulbs are coming. Calculating this one. Listen me. Okay, let's do the calculation. So for bulb 1, okay, for bulb 1, what will be the resistance will come? So power equal to V square by R. The resistance equal to, right now, power equal to V square by R. The resistance we can write it V square by P we can write it. Okay, so what is the voltage? 200 square, and power is what? 50 watt. So if we calculate that one, what is the resistance we are getting? So R1 we will get it as what? 50, that is 800 ohm, isn't it? Okay, so we got it how much? 800 ohm we got it. For B2, if I calculate, what it will come? R2. So this voltage is 100 square, right? And power is 50. So we are getting 100 into 2, 200 ohm we got it. And for B3, what is the resistance will come? So B3 resistance will come 200 square divided by 100. So 200 into 2, 400 ohm will come. Okay. This is what we have, the bulb 1, bulb 2 and bulb 3 resistance. Okay. And now see, the bulb 1 and 2 are connected. You can directly see that and answer that. Okay. That the bulb 3 is going to get fused. You know, bulb 3 is going to get fused. You can even directly tell, right? Why? See, 100 watt bulb is there. 200 volt when it is connected, 100 watt it will consume. But what is the voltage across this B3 bulb? Is it 300 volt? So that means what? That this B3 is going to get what? Fuse, right? You can calculate it also and tell the same thing. How? You see. Now you check it. 800 and 200. What is the R equivalent will come? So the upper branch has what equivalent resistance? 800 plus 200. 1000, na? Tell me, B1 and B2 will give me what equivalent resistance? 800 plus 200, that means 1000. And lower branch B3 will give me what resistance? 400. So check it. If I calculate the current in these two branches, can I say that the lower branch will have current? Voltage is 300, resistance is 400. Upper branch, if I calculate it, can I say this current is 300 voltage? Not 300 is not the voltage across B1 and B2. It's a combination of B1 and B2 which gives me 300 voltage. Okay. So 300 divided by what is the resistance? 1000. That is the current in the upper branch. So now if I want to calculate power in each resistor, P1, P2, P3, let's check it how much it is coming. P1, how much it will come? This is the I, right? What is the current in the bulb 1? 0.3 ampere. And resistance of bulb 1? 800. So how much we are getting? 0.3 into 0.3. 0.098 into that one. So 72 will come. 72 watt. Can you tell me what happened with the bulb 1? What happened with the bulb 1? 0.3 square and its resistance is 200. 9 into 2, 18 watt. What happened with the bulb 3? 3 by 4 square, है ना? Bulb 3, what will happen? Current is 3 by 4 and the resistance is 400. How much is that coming? 3 into 3, 9 by 16, right? 9 by 16 and 16 if you do it, 25 into 9, 225 will come. Can you tell me which bulb get fused here? After calculating the power, what we came to know? Rated power of the bulb 1 is 50 watt. Matlab, the maximum power which can be consumed in the bulb 1 is 50 watt. But you see here, what is the power getting consumed in the bulb 1? 72 watt. So that means what? The bulb 1 get fused. Understood? What will happen with the bulb number 1? It will get fused. Fuse means what? It will burn. The filament will what? Burn out. P2, that will remain safe. P3, 225 watt. That is also getting fused. Understood? Or burn out. So tell me, if I ask you in this question, what is the power consumption? What you will answer? 18 watt? No. Because the moment bulb 1 will get fused, the bulb 2 is connected in series. Isn't it that circuit will break? So in this question, what will happen in this given circuit? If I apply 300 volt, what is going to happen? None of the bulb will glow. Understood? If the question asks which bulb will glow, bulb will be not glowing, right? So here what happened? B2 is safe. B2 did not get fused, right? B2 power consumption is still less than the rated power. But why it is not giving us any power? Why it is not glowing? The simple reason is what? That B2 is in series connection with B1. So if B1 get fused, what will happen? The resistance or the bulb which is in series with that B1, that will also get circuit broken. So bulb 2 is still safe, but it will not give us any glow. The bulb 2 will not give us any kind of glow. And B3, that also gets fused. Understood? So how do you calculate it and know that which bulb is getting fused, which bulb is still working? By calculating the power consumption. If power consumption comes more than the rated power, you will say that particular bulb is getting fused. If it comes less than the rated power, then it is safe. Understood? So this is about the electrical appliance and its rating. Please tell me, understood? Now, till now what you have seen in any question, we have only connected the capacitor or only connected the resistor. Now we are going to discuss about the RC circuit. Okay, RC circuit means what? That in a circuit we are going to connect resistance as well as capacitor, both of them. Okay. Okay, what we are going to do it? We are going to connect a resistance and a capacitor, and let's say a battery is there, and this symbol is called for the switch symbol. Okay, now battery has EMF E, resistance is R, capacitor is C, and this is called the switch. Right now the switch is what? Open. Okay. Right now the switch is what? Open. Capacitor is initially uncharged. Capacitor is what? Capacitor is initially uncharged. Uncharged means what? There is no charge on the capacitor. There is no energy in the capacitor. No energy is stored in the capacitor. Now what we are going to do it, we are going to close the switch, and after the closing the switch, the capacitor will start getting gradually charged, and finally it will get what? The fully charged. Understood? Finally what will happen? The capacitor will get fully charged. Okay, then it will be called a steady state condition. So in the RC circuit, there are two type of RC circuit. One is called charging of capacitor, and other one is called discharging. Okay, RC circuit we have two type of charging. Okay, charging the capacitor. When the capacitor will charge, if initially there is no charge on the capacitor and you connect it with the help of a battery, then what will happen? Gradually the capacitor will acquire the charge. That is called charging the capacitor. And the second one is what? Second one is the discharging the capacitor. So in the discharging circuit, what will happen? In the discharging circuit, capacitor will be already given the charge and it will be connected through a resistor, and then the circuit will be completed. So that what will happen, that when you connect the circuit, when you complete the circuit, then the capacitor charge will start decreasing, and finally it will become what? Zero. Okay, so first we are discussing about what? The first case we are discussing in the RC circuit is charging the capacitor circuit. Okay, how are we going to charge the capacitor? Understood? And how the charge as a function of time will come, what will happen at the initial condition, means just after closing the switch, long time after closing the switch. That is what we have to learn it. Okay, so here what happened, this switch is closed at t equal to 0. What we did, at t equal to 0 we just closed the switch. Initially the capacitor has how much charge? Zero charge. Okay, so what will happen, if we close the switch, current will start flowing. This is how it will flow, isn't it? So if I want to find out charge on the capacitor as a function of time, we should apply the loop law, right or not? Can we apply the loop law? A, B, C, right? I'm going to apply the loop law for A, B, then C, and then again I came back to A, right? Do you remember loop law? Part of the loop also you have applied the Kirchhoff's law, isn't it? Kirchhoff's voltage law. That time your starting point and end point was different. So one place you are writing starting point potential VA and end point was different. So you were writing the end point potential as VB. But here what will happen? Starting point, end point are same. So VA and VA you will write it. Both will get cancelled out, right? So that's why. Even you want, you can write it like this. You are starting from A. So let's write it VA. Now we will go from A to B. A to B means negative terminal of battery to positive terminal. A is connected to negative terminal, B connected to positive terminal. So A means low potential, B means high potential. Low to high potential. So plus, how much plus? Plus EMF of the battery. Now, when we go in the direction of current, high to low potential, so minus R. Direction of current, high to low potential, this capacitor will get positively charged, this one will get negatively charged. How much is the charge on the capacitor? Let's say something Q. The potential difference will become Q by C. Where did I reach now? I again reach the point A. So that's why you see this equation becomes like this. E minus IR minus Q by C equal to 0. and we call that summation of potential difference is equal to zero. Actually, it's a why it is coming equal to zero. The reason is what becoming zero is the simple reason is what that when you write the summation of potential drop, you are starting with a particular potential and you are again going to finish it at the same potential. So that's why the summation of potential is becoming zero. Understood? Please tell me, clear up to this? Now we have to just do some calculation and we'll get the answer. What is the current flowing in the circuit? Something I. What is the charge on the capacitor? Something Q. Right? Now, if I simplify it, what I am getting, we want to find the charge as a function of time. Na? So can I write it here? Uh, I into R one side and E minus Q by C. Check it. E minus Q by C, we can write it here. Hai. And other side we have sent the IR. So this is R and current can be written as dq by dt. And if you simplify here, CE minus Q by C will have. So we are getting what? dq by CE minus Q, right? Q I am sending one side, time I am sending the other side. And what we have? RC and dt we have. Integrate it. Now tell me, in the integration t equal to 0, what is the charge on capacitor? Something 0. Right now, question said initially the capacitor was uncharged. है ना? And when we connect it to the circuit, what will happen? This capacitor will start getting charged. Okay. So now if you write it, what is the integration will come? The dq by c minus q, if you do it, its integration will come ln c minus q, right? And minus will come, right? No, minus q is there, na? So minus will come. Can I send the minus other side? It will become T by RC. Oh, upper limit, I forget to keep it. Lower limit is what? Initially at T equal to 0, when you just close the switch, there is no charge. And the second upper limit will be what? At T equal to T, some charge Q is there. Now let's put the limit on the left hand side. Right hand side already kept the limit 0 and Q. So if you keep the limit, it will come ln C minus Q by C, right? ln A minus ln B it was coming. Ln A minus ln B, you can write it as ln A by B. And this is what? Minus T by RC. Ln log or logarithm, if you remove it, it will become e to the power. So what we have? C minus Q by C e to the power minus T by RC. So if you simplify this, I'm just directly writing it. C, send it one side, then send it other side. So it will become CE into 1 minus e to the power minus T by RC. This is the charge on capacitor as a function of time. Understood? This is what? Charge on capacitor as a function of time. You can see that what is the maximum charge on the capacitor? And when it is going to happen? It's going to happen at t equal to infinity. Maximum charge on the capacitor is going to be what? At t equal to infinity. T equal to infinity is also called as steady state condition. Steady state means what? That charge on capacitor stopped changing. In the steady state, what will happen? Whatever charge has come to the capacitor, the same amount of charge will remain constant throughout after that. Okay. So that state is called as the steady state. Okay. Please tell me, clear about the charge on capacitor as a function of time? So now let's discuss about a few things about the RC circuit. What is the charge? We got it. CE 1 minus e to the power minus T by RC. We got it. What will be current as a function of time? So if you want to know the current, what you will do? You will differentiate it with respect to time. Differentiate it. C constant, one differentiation 0 minus e to the power minus T by RC and It's a differentiation. One more time, minus 1 by RC will come. CC get cancelled out. E by R into e to the power minus t by RC will come. So that is the current as a function of time. Understood? Charge as a function of time, we got it. Current as a function of time, we got it. Third thing, what is the voltage across capacitor? Not voltage across resistor. Because if you want voltage across resistor, you can just write it I into R, isn't it? Voltage across the resistor, how much it will come? I into R will come. But what about the voltage across capacitor? The voltage across capacitor, if you want, you should write it charge by capacitance, isn't it? What is the voltage across a capacitor? The voltage across capacitor is charge by capacitance, isn't it? So the third thing you can calculate it here, voltage across capacitor. So you will write it charge by capacitance. See the first expression. Look at the first expression. This is the first one. This is the second one. Look at the first expression. Charge is given CE 1 minus e to the power minus t by RC. Divide by C, so how much it became? Has it become e into 1 minus e to the power minus t by RCVR? So that third one is what? Potential difference across capacitor as a function of time. What else I can calculate it here? Can we calculate energy stored in the capacitor as a function of time? So what will be energy stored in the capacitor as a function of time? So charge of the capacitor is also known to us. Potential difference across capacitor is also known to us. Either we can use it q square by 2c, or what we can do it, we can use it half cv square. So out of these two, any one we can use it, okay? Whichever you think easy for you, you can use it, okay? So we can write it q square by 2c will come. Again, energy also becomes what? As a function of time. Understood? Of some time you will see this expression is given in the format like this. Sometime you will see it will be written like this: q equal to q max 1 minus e to the power minus t by tau. What does it mean? That means what? That CE, or what is the charge on capacitor? What is the charge on the capacitor as a function of time when you write it? You see that maximum charge on the capacitor. Can I say that it's going to be this only? Look at the expression. If you put it t equal to infinity, that capacitor is going to have the maximum charge. And this RC is called as what? That RC is called as the time constant of RC circuit. What is this tau called as? Tau equal to RC. That is called as the time constant of RC circuit. Clear? If I want you to plot me some graphs, what kind of graph you will plot it? Tell me. If I ask you to plot me a graph of charge versus time, charge on capacitor versus time, tell me what kind of graph will come? Will it be an exponential rise and finally it becomes what? The constant, isn't it? What is the charge as a function of time? It is exponential rise, and finally at t equal to infinity, what happened? That becomes constant. Understood? Now, next one, if I ask you, tell me what is the graph of current versus time? Okay, what is the current versus time? Look at the graph of current versus time. Is it an exponential decay? See that current versus time. Is it an exponential decay? Initially, there will be large current in the circuit, and as the time progresses, the current in the circuit will decrease. And at t equal to infinity, what is the current going to become? That is going to become zero. Understood? So this graph is going to be what? An exponential decay. Understood? You can call this charge as Q max. I am not writing C because if it is a simple circuit means what? One resistor, one capacitor, one battery. Then the answer will come C and all these formula you can apply it. But sometime not. Sometime not. In that case, what you have to do it? You have to draw the circuit at t equal to infinity. You have to draw the steady state circuit to get the answer. Understood? You have to do what? You have to draw the steady state circuit to get the answer. Understood? Please tell me, clear up to this, what we have discussed? So, what does it mean by t equal to 0 and t equal to infinity? In a RC circuit, the 2 point is important, okay? What are the 2 points? First point, let's discuss about initial condition. Okay, initial condition, or sometime it will say t equal to 0 condition, or sometime the question will used just after the switch is closed. Just after the switch is closed. Understood? Meaning is what? That t equal to 0. T equal to 0 means what? Initially the circuit is open, no current, nothing is flowing in the circuit. But if I close the switch, right, then suddenly what will happen? The current will start changing in that. So we want to know that what is going to be the circuit condition just after the switch is closed. Okay, next moment when the switch is closed, just the next moment what is going to happen. Okay, that is what we want to understand in this part. Okay, so initial condition, you see that what is the charge initially? Can you tell me what is the charge initially? If I put it t equal to 0 in my expression, what is the charge I am going to get it? Charge expression we have now. Let's keep it t equal to 0. How much we are getting the charge? 0. If charge is 0, what is the voltage across capacitor at t equal to 0? That is also 0, isn't it? So at t equal to 0, there is no voltage across capacitor. Please see carefully. No voltage across capacitor. So the important point what we have, that at t equal to 0, capacitor will behave. Capacitor will behave. If there is no potential difference across any element, isn't it we say that it is short circuited? Tell me, any element doesn't have any potential difference across it. It is connected in the circuit, but it does not have any potential difference. That means what? We will call that element is short circuited. So capacitor will behave like what? Like short circuited. And why it is happening? Because initially t equal to 0 condition, potential difference across capacitor is 0. At t equal to 0, initially the potential difference across capacitor will be what? 0. Understood? So that's why capacitor is behaving like what? It is short circuited. Clear? Now, if capacitor is behaving like short circuited, what we will do? We will replace the capacitor by just a wire, or we will short the capacitor. Okay, now tell me, what are the other things we learn from that? Q equal to 0, I equal to maximum, delta V across capacitor equal to 0, isn't it? So these are the things we have learned at t equal to 0. I will take an example and I will show you how the circuit will look like at t equal to 0 and t equal to infinity. Understood? Capacitor will behave like, but this is the most important thing about the capacitor properties just after closing the switch. Okay, just after closing the switch, a capacitor will always behave like what? The short circuited one. Okay, please understand this condition. Second condition is final condition, they will write it, or in the example they will write it as t equal to infinity condition, or steady state condition. There are many names of that. Okay, steady state condition, or sometime they will write it long time after the switch is closed. Long time after switch is closed. Understood? Matlab you have kept the switch closed for what? A very long duration of time. Means you are allowing the capacitor to what? Getting fully charged. Okay. So that is called what? Final condition. Or sometime in the question they will write draw the circuit and find everything at t equal to infinity. Or sometime they will say in the steady state condition, tell me what is going to be the current, everything. Okay. So now tell me what I can write, how the capacitor will behave at t equal to infinity. See that t equal to infinity, is there any current in the circuit? Please tell me, is there any current in the circuit at t equal to infinity? No, na? So that means what? Can I say t equal to infinity? Capacitor will not allow any current to pass through it. Capacitor will not allow any current to pass through it. So that's why what we can say at t equal to infinity, how the capacitor is going to behave. Capacitor will behave like open circuit. If there is no current flowing through a branch, what does it mean? That branch must be opened, enough, because current always flows in which path? Current always flows in closed path. If current is not able to flow through a particular branch, that means that branch must be open like. Okay, the capacitor will behave like what? Open circuit element. Understood? So what are the different thing we understand? The first thing, capacitor is going to behave like open circuit element. What about the charge? This time charge on capacitor will be maximum. What about the current through that capacitor branch? Zero. What about the delta VC? The delta V, matlab potential difference of a capacitor will become Q max by capacitance. Please tell me, understood these three things? Again, energy stored we can also find out, isn't it? What will be energy stored in the capacitor? It will be maximum. Why maximum? Because charge on the capacitor has become maximum. If charge on the capacitor has become maximum, that means energy stored is also going to be what? The maximum. Understood? Please tell me, clear? Tell me, clear this one? So now let's take an example and try to understand what does it mean by t equal to 0 and t equal to infinity. Let's say a resistance is given to us as R. There is a capacitor connected here. There is another resistance R here. And there is an ideal battery connected here. Right, this is R. This is the battery EMF E. Now tell me, this is the circuit given to us, okay? Switch is closed at t equal to 0. Now, we have to answer this thing. Find current in each branch. Okay. Find current in each branch. First thing, at t equal to 0, or you can say that just after closing the switch, sometimes they will make a symbol of switch and they will say that find the current in each branch just the next moment when the switch is what closed. Okay, so find the current in each branch. Second thing, find out at what t equal to infinity. So chaliye please redraw both the circuit at t equal to 0 and t equal to infinity, and tell me what is the current in each branch is coming. At t equal to 0 how much it is coming, and t equal to infinity how much it is coming. Okay, both of you try it and tell me how much is this coming. How much is this coming? Actually, let's draw the circuit at t equal to 0 and one more time draw the circuit at t equal to infinity, because we have to solve this question at two different instants. That's why we will draw the circuit at t equal to 0 and t equal to infinity. Okay. In the solution, first part, I'm going to do it. I'm going to draw the circuit at t equal to 0. See, t equal to 0, what did we learn about the resistance? Don't do anything with the resistance. Draw as it is given in the question. Battery as it is. This is my circuit, right? R, R. Ab t equal to 0, what is going to happen? T equal to 0, this capacitor is going to be short circuited. Short circuited means what? That this is the one end of the capacitor, this is another end of the capacitor. I am going to connect it by what? Just a wire. Understood? I am going to connect this one as with the help of what? A wire. Now you see that what you are going to get it. If this is got short circuited, see that this R and this R. How are these two connected now? So they are connected in parallel. So what is going to be R equivalent? R and R in parallel. So R by 2 it will become. What is the total current in the circuit? So E divided by R by 2 will come. That means 2E by R. So from the battery, how much current we got it? 2E by R. The current will reach here. It will distribute in these two branches. Both are having parallel combination. Both are equal. So equal distribution will happen. E by R, E by R. Current will reach here. Current always follows which path? Current always follows the least resistance path. And this is going to be current in each branches. Understood? That is the t equal to 0 situation. Same question, they ask me that what is going to be the current at t equal to infinity. So t equal to infinity, if I do it, again, I will not do anything with the resistance and battery. We have to only do the modification in what? We have to do the modification in the capacitor. Okay. Now this is the EMF, this is the R, this is the R, and this is what we have the circuit. At t equal to infinity, what do we learn? That capacitor is going to act like an open circuit. I have opened this. Up, what happened because of opening of the capacitor? You see, a very interesting thing happened because of opening the capacitor. The moment I open the capacitor, isn't it this upper branch circuit got broken? Tell me. That capacitor part got opened. That means the upper branch got opened. That means, can I say, at t equal to infinity, there is not going to be any current in this branch. Understood? And why this happened? Because when I opened the capacitor, there was a resistor connected in a series with the capacitor, right? So because of opening that, what happened? That resistance also got opened, right? So that means the only resistance in this circuit is working is this R. So what is going to be the current now? So current will be EMF divided by resistance R. This current will reach here. The current will go directly in this branch as E by R, E by R, E by R. And there will be no current in this resistor. Understood? Now, next part of this question. Let's discuss the same question and learn about the two more things. What is the charge on capacitor at t equal to 0? They will say, sir, 0. Voltage across capacitor as t equal to 0. 0. Energy is stored in the capacitor at t equal to 0. 0. No charge, no voltage. Okay. Now tell me all these things at t equal to infinity. Understood? At t equal to infinity, what is this? Okay, chaliye, let's do one thing. Although we have shown it like the capacitor got opened, does it actually the circuit got broken? No, actually the circuit doesn't get broken. But what happened in the question that when the t equal to infinity reached, there is no potential difference across the capacitor. Sorry, resistor. Okay. So if I call this point as something A and let me call this point as something B, can I say all these point has B potential? Can I say this potential has A? And please tell me, can I say this potential is also A? You'll say that no. There is a resistance na in between. But look at the property of this resistor right now. At t equal to infinity, the upper branch resistance, does it have any current in that? No. And if there is no current in the resistance, then we can say that potential difference across that resistor is 0. So it means what? Whatever is the VA minus VV, this point is connected with this red point. No? Look at these 2 points. Same way, look at these 2 points. So potential difference across capacitor. Potential difference across capacitor. How much is that? The potential difference across capacitor is VA minus VV actually. Right? Potential difference across capacitor is what? VA minus VV. So how much is VA minus VV? So can I write it? VA minus VV will be equal to E by R into R. Please tell me. I'm using this resistor property. What is the current in this branch? Current in this branch is E by R. Resistance R. So VA minus VV will be E by R into R. This one will get cancelled out. So what is the potential difference in the steady state? In the steady state, the potential difference across capacitor is E. Understood? So steady state na the charge on capacitor is maximum. It is the steady state when charge on capacitor is maximum. So what is going to be Q max? C into E. What is maximum energy stored? CE square by 2C. Q square by 2C, we can write it. Understood? Let's take another example of the same type. Okay. In this example, what is given to us? Let's say that is the resistance R. There is a capacitor. There is another resistance connected like this. Like this. Like this, it is given to us. Okay. This is also R. This is R. This is EMF E. This is R. This is capacitor C. Find current in each branch. Again, the same question is there. Current in each branch. First thing, initially or just after the switch is closed. Second thing, t equal to infinity. Okay. So tell me, at t equal to 0, what is going to happen? If I'm going to redraw my circuit at t equal to 0, what did we learn about t equal to 0? We know that t equal to 0, capacitor is going to be short circuited. Okay, first draw the remaining part of the circuit. Draw the capacitor last. Is this my circuit? This is my actual question. Are everything I have drawn? Look at this question. This is my actual question. Okay. R, 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 and this is the EMF of the battery. Now, what I am going to do? I am going to short this capacitor. I have connected them just a wire, right? Now, you see what happened because of this shorting. Because of this shorting, can I say that the another resistance? Look at this resistor R. Can I say because of shorting, this resistance R also got shorted? Please tell me. So that means that R is also not going to have any current. Now, if you look at this one, see that this lower branch has what resistance? R and R in series, 2R. And upper branch, this R. So what is the R equivalent we are getting? 2R and R in parallel. 2R into R by 2R plus R. So that will come 2R by 3. So what is going to be the current now? EMF divided by 2R by 3. So 3E by 2R, that is the total current in this branch. This is the total current in the branch, 3E by 2R. It will reach here. Is that going to distribute in the two branches here? In these two branches? What ratio? 1 is to 2 ratio. 3E by 2R is there. You have to distribute it into 1 is to 2 ratio. This is a smaller resistance. Can I say that it will have 2E by 2R current? And this one will have E by 2R current. 1 is to 2 ratio I have distributed. Now, current will pass through this one. It will go to this branch. And here what will happen? Current will reach here. And will it go through this short circuited element? Understood? This is how the current will be flowing in the circuit at t equal to 0. This is the current in each branch. Now, the next thing they are asking in the question, what is the current at t equal to infinity? Current at what? T equal to infinity. So t equal to infinity, what I have to do then? I have to again redraw the circuit, isn't it? Please tell me. at t equal to infinity. Again, we have to redraw the circuit. What happens at t equal to infinity? How the capacitor behaves? Can I say capacitor behaves like open circuit? The moment capacitor get opened, what is happened? Then this R will start working. Understood? So now if you calculate again the same these things, what will happen? Check it and tell me. Now you see that. Do you see that these two are, check it. This R and this R. Now are they connected in series? The two R it will come. Lower branch R and R connected in series. 2R will come. So R equivalent, how much it will come? So can I say R equivalent will come? 2R and 2R connected in parallel. Upper branch 2R, lower branch 2R connected in parallel. So 2R and 2R connected in parallel. Wait. 2R and 2R is in parallel. So R equivalent, how much it will come? R will come. What is going to be current? E by R will come. Distribute them, right? What is the current here? E by R. It reaches here. Upper branch, lower branch, equal resistance. So current will equally distributed. E by 2R, E by 2R. Current will reach here. Here it will go. E by 2R. Same it will go through this one. Now the circuit is complete. So please tell me, understand what we have discussed at t equal to 0 and t equal to infinity. So next class, a little bit about transient condition means at any time t, not 0 and infinity. If some other time is given, then how we will calculate? That is what we will learn, and we will learn about the discharging of the capacitor also. Okay. So please tell me what we discussed. Understood? Please tell me.
Listen.
Right. Okay. So let's meet it tomorrow. Okay. Now.